Chemistry by Sir Sadiq Amin.
Assalamu alaikum, dear students. These videos are recorded for your educational purposes, so please keep watching the video. And if you have any problem, you can contact on my number, or you can put a question there in the comments. Inshallah, I'll be answering you as soon as I get the chance. Thank you very much. Keep watching the channel. Things which we need to be talking about the ionic radii. First of all, you need to understand that if we are talking about sodium and sodium plus 1, this is one of the exam question. Which one is larger in size? Sodium is larger in size, and the other one, sodium positive, is smaller in size. The reason for that is that after losing one electron, the nucleus of sodium positive ion, which is having 11 protons, is attracting 10 electrons now. Before, the same 11 protons were there and they were attracting 11 electrons. So now the nucleus is more powerful. It is using the force of attraction over 10 electrons now, right? So that's why sodium positive is smaller as compared to sodium. Listen to it very carefully. Second, now, when we talk about the negative ions are larger than their atoms. And the reason for that is, if I take, let's suppose, nitrogen now, nitrogen is smaller in size as compared to nitrogen minus 3. This is the second thing about the ions which you need to know. And why it is smaller, why nitrogen minus 3 is larger? Because the force of attraction which nitrogen nucleus was applying on the electrons, there were 5 electrons before. Okay? Now you brought 3 more electrons. Bringing 3 more, repulsion is there, so the size has to be adjusted. So nucleus is the same, but more electrons are there now. Now this nucleus cannot attract those electrons. So 3 more electrons when you bring to it, it increases the size, right? So nucleus is now not that much effective, so that it can hold those electrons the same way. Now the third point which you talked right now, keep always in your mind, when we talk about the negative ions and the positive ion comparison, the negative ions are always larger. Let me repeat, negative ions are always larger in size as compared to the positive ions. Are you getting my point? But how do you compare it? The comparison should be between plus 1 and minus 1, between plus 2 and minus 2, between plus 3 and minus 3. This should be the comparison. The way Abdul Saban you have compared, you are comparing plus 1 with minus 3. Plus 1 is much more smaller as compared to minus 3. So this is first of all unjustifiable to compare something which is minus 3 with something which is plus 1. But again, I'm telling you that negative ions are larger as compared to the positive ions. Now you compare minus 3 with plus 3. You can see plus 3 is much more smaller. This is plus 3. Come on.
It's 3 times smaller.
See this is much more smaller in comparison to the minus 3. This is minus 3. So minus 3 is much more bigger. Now as far as minus 2 is concerned, compare those also. Right? I hope this is the... So there are 3 points, keep that in your mind. Shall I move on?
Yes.
Okay, now this concept is related to the ionic bond now. It's called polarization and polarizing power of ions. Let me explain that to you. We have a positive ion and we have a negative ion. We have sodium in the ionic compound positive and chloride minus 1. Polarization and polarizing power. These two things I need to explain to you.
The positive ion, which is losing its electron, sodium was having, what was the configuration? 281. And for chlorine, what was the configuration? It was 2, 8 and 7. Sodium was losing this electron to chlorine. Before we have studied that there is a 100% loss of electron from chlorine, or transfer of electron from sodium towards chlorine, right? So the configuration was 2, 8, still it is 2, 8, and when it's losing these electron, sodium lost this one and chlorine fulfilled this one, this will become 8. So sodium ion is 2, 8 and chloride ion is 2, 8, 8. Okay? Now the point starts from here. Is sodium losing the electron completely, or it's not losing completely? So the X-ray diffraction, which is called the electron density map, we'll follow that. If sodium is losing the electron completely, then it should the structure. If there is a complete loss of electron by sodium, how will it look like? And how will chloride look like? Okay, so this is the electron density map. If sodium is losing electron completely and chloride is gaining completely, while sodium has no authority over its electron and chloride is completely having authority on that electron, how will it look like in electron density map? This will be the structure in electron density map for sodium, right? Let me write Na with plus charge. And the structure for chloride will be like this. These two structures will be completely separated from each other. Now this is chloride. They should be completely separated from each other. But in fact, when we study the structure, this is what we were assuming, right? But what we got experimentally from electron density, this shows 100% ionic character. Keep this in your mind. This shows 100% ionic character. Okay? This is 100% ionic. Look at it. It should look like that. I'm saying it should look like that. It doesn't mean that it is like that. Experimentally, we have proved something different. And what we proved? When we did the electron density mapping, we saw something like, for sodium, I'm drawing for sodium first of all. For sodium, come on. We saw that sodium structure stays the same, but for chloride we saw something different. And what was that? See the structure for chloride now. We saw the structure a little bit disturbed. It was not completely circular. Are you getting my point? Let me remove some circular part. It was not completely circular. It was a little bit distorted or disturbed towards sodium. Not touching sodium, but it was moving towards sodium. So this is called polarization. The negative ion is polarized. Okay? the negative ion is disturbed. The structure is called distorted. This is distorted. This is called distortion. So the negative ion will be distorted and the positive ion has the power to distort it. This deformation of structure never happened to sodium or the positive ion. This will always happen to the negative ions. Are you with me?
Yes, sir.
Okay.
Yes, sir.
So this means that it's not 100% pure ionic. It means that sodium was trying to lose the electron. It has lost the electrons out of its boundary, but still it is feeling something for it. While chloride has accepted the electron, but not completely, like 70%. It is around its boundaries somewhere, very close to chlorine, far away from sodium. But sodium has some feelings for it. That's why sodium is trying to pull it towards itself. That's why the structure is distorted. Are you getting my point?
Yes, sir.
So it's very difficult to find 100% ionic character. Are we clear with this?
Yes, sir.
Okay. Every element is given certain value depending upon the attraction towards the shared pair of electrons. Okay? And that value is called the electronegativity value. Every element has an electronegativity value. It is depending on the force of attraction towards the shared pair of electrons. Okay, that's the value. An arbitrary value of 4 is given to fluorine because fluorine is having the maximum force of attraction towards the shared pair of electrons. And then the comparison is made with other elements. Okay, so when we are working on the bonding, we are actually working on the, see this structure now, 100% ionic character. This is 100% ionic, which is not possible. Then we have the second character, the distorted one. The negative ion is distorted here. This is the distortion area. This shows percentage ionic character. Okay, or you can say percentage covalent character in it. Then moving on to the 100% covalent, when it's touching, then this is covalent character. Now this area is the covalent character because it's touching. When we are drawing the structures of ammonia, how do we draw that structure? We were drawing this nitrogen and then shells are touching in this way. So this is ionic. Okay. So when we work on the ionic, this is covalent. When we work on the covalent must be touching. This touching is called overlapping. Overlapping of the orbitals. Are you getting my point?
Yes, sir.
So, the electronegativity values, they are given to all the elements. Fluorine is given a maximum of 4. Halogens are having the maximum values, followed by chlorine 3.5 in this way. There's a table given there in your book. So we'll discuss that, but I'm just giving you an idea. So when I'm bringing, now the electronegativity values are very important. When we decide about the bond, we decide on the basis of the electronegativity difference. Okay? Now keep this point in your mind. This point is very, very important, and that's the last point of this lecture now. I'm writing it here. There is a scale for all of us. about the electronegativity values. I'm drawing a line here. This line is starting from 0 to 4. That's the electronegativity values. Okay, and there is a central point. That central point is 1.7. Now I want everyone to focus on this because this is not given in the book and very, very important to understand. Electronegativity difference if you want to bring two atoms together like sodium and chlorine, you have to find the difference of electronegativity between these two elements. Okay, if the difference is 0, you get 100% covalent character. If the difference is 4, which is not possible at all, then you get 100% ionic. Are you with me?
Yes, sir.
Now in between, focus on this point, very, very important point. In between 4 and 1.7, you find polarized ionic. Okay? And here 0 and 1.7 you find polar covalent. I want you to go through this video again and again to see it. Tomorrow I'll brief you about the rest of it and we'll decide which compound is ionic, which compound is covalent. Okay?